had seen how to create a thread by extending a thread class, right? The another way is by implementing the runnable interface. Let's see how it works. Right? Let's go to the programs and then write a simple program. Java class abcdfgh. By implementing the runnable interface. Implement runnable. See, runnable is available in the java.lang package. As soon as you put the runnable interface, usually what happens when you implement the interface, that interface will have some methods, and you need to override that methods. Right? You need to implement it. Right? This is the abstract method. Right? This doesn't have any implementation. This is what we learned about the methods in the interfaces. Right? As soon as you implement any interface, you need to override that interfaces, right? Immediately it has giving the red line on that line. You just click on it, click on the red bulb, right? You see the implement methods. You will see it is showing the run method. This is what we are going to implement. A runnable interface. We are overriding the run method. Okay. So here I will write for loop int I equal to 0, I less than 5, I plus plus. And then s out of I. Now I'll write manager class for this, h manager. svm, write the main method. Create the object for class h. h1 equal to new h. h1 equal to new h. Thread. Here thread t1 equal to new thread of h1. We'll pass the object of class h, which is implementing the runnable interface. Okay. Now I'm starting the thread t1 dot start. Okay. Now I'll have for loop for int I equal to 10, I less than 15, I plus plus. Clear? This is the second way of implementing multi-threading concept, that is by implementing the runnable interface. First, what I am doing, I am creating a class that implements runnable interface. As soon as I implement the runnable interface, we have to override the run method. So I put the logic inside the run method here, right? Next, I am creating another class, that is a manager class, for which I am writing a main method, right? And then within that main method, I'm creating a simple object for the class h, that is h1 equal to new h. And then I'm creating another object for thread class. Thread is a class available in Java itself, right? Thread t1 equal to new thread of, I am passing the object h1 that we created here, right? That's when this thread belongs to this class, because we are passing the object of h here, right? For example, if you pass the object of some other class, then this thread will belongs to some other class, right? So whatever the object you pass here for while creating the new thread, that thread will be belonging to that particular class only, right? Then we are calling the start method on the thread t1. After calling the start method, we are calling, we are just simply writing one for loop method, right? So now this will be a sequential or simultaneous execution. This will be a simultaneous execution. 0 1 2 3 4 11. Okay, for the first okay, no, it has mixed up. See, first it has printed 10 from the second for loop, I mean the main for loop, and then again it went back to the class h, right? It has printed and again it came back to this, right? This is just another way of implementing the runnable, implementing the multi-threading. Just I just want to show how it was earlier, right? Yeah, you see the difference, guys, between G and H, right? In the first approach, that is by extending the thread class, you just create the object for the class which is extending the thread class, and then you call the start method. Simple, right? It is just two steps. But here, when you are using the runnable interface, first you need to implement the runnable interface, right? You need to override the run method, that is mandatory. Without overriding this, you cannot achieve the multi-threading here. And then you need to create the object for the class, and then you need to create the object for the class thread by passing the object of the class for which we are extending the runnable interface, and then we are starting the thread. This is bit lengthy process compared to the first approach. This is bit lengthy process compared to the first approach, but the most efficient and most widely used approach is the second approach. This is the most efficient approach, right? This is an important question. It will be asked like what are the various ways to implement the multi-threading. You will tell there are two ways. One is by extending the thread class, and other one is by implementing the runnable interface. Then the next question will be what is the better way of implementing the multi-threading. You should say runnable interface, by implementing the runnable interface. Clear, guys? Any doubts? Can I move to the next one? Right. Now let's try to mix up both the ways. As I extends public void run method. Um, create another class A B C D F G H I J. And implement the runnable interface. Implement method, run method. Right. I'm just copy pasting it here. run method. Right here I'll put 10 to 15. I'll create a new class ij I and a manager. SVM class I. What is the way that we can create a income equal to new I? J1 equal to new. It's common. Right. So how do we start the thread for the class I? How do we start the thread for class I? It is simple I1 dot start. Right. J1, what is the approach for starting the thread for J1? I need to create the object for J1. Thread T1 equal to new thread of J1. I need to T1 dot start. Let's run the program and see. Now it will be sequential or simultaneous. This is again sequential, sorry, simultaneous only. But here for the first time it has become simultaneous. But if you rerun it, it should change. Let's rerun once again. All this behavior, which one to run when, will be decided by the thread scheduler within the laptop, within the JDK thread scheduler. Okay, we don't have any control. Sometimes it behaves the way that we expect, sometimes you cannot expect the output. Fortunately here it is showing whatever the way we usually expect, but this is not true always. If you keep running multiple times, the output will definitely change. Maybe thread schedule, because we don't have any control on the thread scheduler, right? I just put the comments here. Let's write another program. IJK. Just simply extend the without even this. I'll, I'll not put any body here. I'll just create a class, right? And then I create the K manager PSVM K1 equal to K, K1 dot that's in S out of K1 dot get ID, okay, S out of K1 dot get name out of K1 dot get priority, then S out of K1 dot get name. So we can change all these values. Okay, what I'll do is I'll change it here. Yes, okay, I'll put some stars here. A1 dot set ID. See, we don't have the set method for ID, so that means we cannot change the value of the ID. Okay, but set name you can change the set name. Right. Set name A1 dot set priority. And A1 dot set demand of changing. Again, I print all the same things. Here, I'm just trying to print the values of various properties of a thread which we had seen in our previous class already, but whatever the values that you get for the first time are the default values. If you want to change the values, you can change the values for few properties but not the every property. For example, id you cannot change the id. This will be given by the thread scheduler that is there in the jdk. Right click, run. First time thread id is 11, name is thread 0, and the priority is 5, and each demon is false, right? And after that, after changing, thread id is still same because we could not change the name, we could not change the id, so the id will become same, but the thread name I changed it to new thread name, right? So that's what you can see the thread name. Earlier it was thread 0, now it has become new thread name, right? Then priority, it was 5, but we set to 10, right? But we it is not changed. Did I print the right one or not? K1 dot get priority, set priority is right. So why it is not changing? Okay, we'll see. Set daemon. Earlier it was false, right? But now it is true because I had set it to true. Okay, but the priority is something which is not changing here. Let's see. Let's check on the Google. Ideally, it should change. set priority. Not working. Set priorities are highly OS specific and on many operating systems often have minimal effect. Priorities help you order the threads that are in the run queue only and will not change how often the threads are running any major way unless you are doing a ton of CPU in each of the program needs to use a lot of CPU. That is also civil right is the implementation for any particular Windows or the template also. Let's keep it simple and go straight to the source. Header and there is a combination for passing resources. Threads with the higher priority are generally executed with threads with the lower priority. Guarantee that the higher. Guys, if you get any such doubts right while working, this is the way that you can take help from Google. Whatever the question that you get, right, you need to understand how to search for it, right? Enter max priority color. T1 dot get priority. See here it is working perfectly fine. T1 dot set priority they are setting to 4 and for T2 they are setting to 7 and they are expecting the output 4 and 7 they are getting it. But why for us it is not coming? Extends thread. So right, K1 extends thread set priority. The default priority is 5. It is always giving 5 only. Okay, we'll see this offline later. Right, I'll look and then I'll come back in the next class. Clear, guys? Any other questions? All right. There is a another concept called synchronization, okay, which is part of the multi-threading only. Okay, synchronization. If any resources are exposed to multiple threads, to avoid the data corruption, we have to use the synchronization. That is a technical definition. Let's try to understand in simple terms. Synchronization, very important topic. Any resources are being used by multiple threads. Avoid data corruption. We have to use synchronization. Synchronization. So we understood that multi-threading is nothing but the multitasking, right? Multi-threading is nothing but the multitasking, right? So that means when somebody is doing some job, it will require some resources, right? For example, let's say uh, we all of us are there, 10 people, right? So all of us are sitting in a shop, right? And all of us, our job is to sit in the cash counter and then take the money or do the billing, right? That is what manual billing. That is completely a manual billing, right? So what happens when all of you together sit on one job and then do the same thing, right? Nobody knows whose income is what and whose outgoing is what, right? It's all mixed up, right? Sometimes we may lose some money also, but we will not understand or we will not come to know because of which person we are losing the money, right? Yes or no? When 10 people are sitting in one cash counter, manual counter, and all of you, without doing any billing or without doing any receipts or without tracking anything, right? What happens? The money will be definitely lost because nobody is tracking it properly, right? Nobody is tracking it properly. The same thing even in the multi-threading also it happens. When the multiple threads are doing the same job, right? Obviously it will be using the same resources, right? When the same resources are being used by the same multiple threads, there will be a chance of the data corruption. That means data might behave properly, data will not behave properly, right? So to avoid that, we need to implement the synchronization. That means when one thread is using any resource, the other thread should not go and use that resource. It should wait until the first thread is completed its job, right? When the second thread is going, all the other threads should wait until its processing is completed, right? So that way we will have the track, right? In our general example, out of all 10 people among us, right, when one person is doing or putting any money in the counter and then he is taking out, all others should wait. The other person also should not go and put the money and then take it back on his own, right? Then we lose the count, right? We lose the money. We don't know which person is putting how much money and which person is taking out how much money, right? Exactly the same way here also. To avoid all that confusion, we need to make sure that all the threads uses the resource in a synchronized way. That means when one thread is using that resources, all the other thread should be waiting. It should not enter to use that resources, right? So that's the understanding of the synchronization. Okay, now let's try to see how this can be achieved through the programs. JK. JKL. Or instead I'll name it as shared. Okay, I want to make this as a shared. This is a shared resource. Shared. This shared class, what do I have? I have a test method. Void test. Inside this, I just have a simple for loop again. Int I equal to 0 in m5 yes out of this is the shared resource. Okay. Now I'll create a class. The class name is L. Okay. This will extend the thread class. Extend. Sorry, it's thread, right? So I'll be using the object of shared S1. I'm not creating the object. Just see. I'm just declaring the object shared S1. Okay. I'll create a constructor for class L. I click on constructor only. Okay, I'll manually write it. L of takes the argument shared S1 is dot S1 equal to S1. Now I'll write the public void run method because we are extending the thread class. So the run method is mandatory to be overridden here S1 dot test. Now I'm going to create another class LM. Class M also will extends the thread. That means L and M will be the two threads. Right? So this also will give the same behavior object of class shared. Okay, clear? Now I am going to create a manager class. LM manager. PSVM create the object of the shared resource. Shared S1 equal to shared. Then I'll create another object shared S2 equal to new shared. Now I create the object for L L1 equal to L of S1, right? So that's what the constructor created, right, in the class L, which takes a argument of type shared. So I have to pass the object S1, right? That is of type shared. Okay. Now I create another object for M1 equal to new M. This also is expecting an object of shared, right? Yes. Yes. Now what I do is L1 dot spot and M1 dot spot, right? If you run this program, we have only let's close all the other things so that here shared is the shared resource. This is a common resource that is being used by two threads. One is with the L, right? Within the L, run method also is calling the test method of S1, right? And in the M thread also, the run method is calling the test method, right? Shared class is a shared common resource that is being used by both L and M. That means two different threads, right? So we are simply starting the through two threads here, right? Two threads here. By looking at it, what should happen? Usually first L1 from 0 to 4, right? 0 to 4, that is what we have, right? From 0 to 5, that means 0 to 4 should print, and then the content of, then it should call the same thing from the thread M1, right? That is again should print 0 to 4. Let's run and then see the output. It's always 0 to 4, 0 to 4, or it will be mixed up. 0 1 2 3 4, 0 1 2 3 4. Okay, this is expected. I mean, this is not expected, but for the basic programmers, they'll understand that. Okay, this is the way it executes, right? Or probably I should increase the number, because since it is just 10, right? I will say 100. When it is trying to print more numbers, obviously it will take more time. That means it will, there will be some more time for the other thread to come in between. Let's see if there are any numbers are mixed up in between. 99, good, 1000. Basically, I wanted to show you that, this will execute in a simultaneous way. That is my intention here. See here, it is all mixed up, right? 15, 16, and then it went to 1. That means this is the second thread is being started here, right? From 0, right? See, it's all mixed up. First thread it started 0 1 2 7 8 9 10 11 14, and then the second thread has started, right? Second thread has just started again in between. First thread has come in between, that is continuing the 14, that is 15, 16. Again the second thread has come in between, printed up to 5, and again the first thread has come from 17, right? That is good enough to understand the sequential, sorry, simultaneous execution, right? See, again it is all mixed up. Here it is 200, again it is 6. Somewhere very long back, the second thread has stopped with 5 here, right? See, here it stopped with the 5, the second thread, where the 6 started after some 200, which we had seen just now, right? See here, after 238, again the second thread has come, right? So it's all mixed up. It's all the sequential, sorry, simultaneous. It's all the simultaneous. That means the same shared resource is being used by two threads, right? Two threads, and it's all mixed up, so we'll lose the data, right? So in such scenarios, how to avoid the data corruption is, you just need to put synchronized keyword here. Synchronized, right? If I run this program now, it should be always simultaneous. It should be always simultaneous. You run 1000 times, you will get the simultaneous execution. See, there is no second thread is starting here. When one thread is doing its job, the second thread will wait. When one thread is doing its job, the second thread will wait. The second thread will start only after 999. See here, after 999, 0 1 2 3 4, right? Now you might ask, even before the multi-threading, everything was sequential, right? After that we learned something that is sequential. And again to fix that sequential thing, sorry, again to fix that simultaneous thing, we are doing something else to make it sequential, right? Do we really need it? Yes, we need it. So whatever we learned before multi-threading is a different thing, right? Where there is no multitasking, it's all one person doing all the things after one by one. But here there are multiple threads using the same resources. At the same time, we need to make sure that the resources are not being lost, the data should not be lost, right? So that's the main intention. So when we do the multitasking, what is the advantage of the multitasking? What is the simple advantage or the basic advantage of the multitasking? You don't have to think in Java. In general, you can say. Anybody can answer.
Time saving.
Exactly. Yeah, time saving. Right. That's the main thing. That's what we are going to achieve here. Right. That's what we are going to achieve here. We just learned with one or two threads here. Right. But see, let's say in my laptop itself is a program. Okay, if I have to, if I don't have the multi-threading implemented in my laptop, I cannot use the IntelliJ when my Chrome is opening, right? Or I cannot record the session when my Chrome and IntelliJ are running, right? I cannot see this showing this time and calendar is also one process here. It's also one program here, right? And charging, this is also one function here. Connecting to the Wi-Fi, this is also one program here, right? Each and everything is a program here, right? If you don't have the multi-threading implemented, you cannot use this many programs simultaneously, right? At the same time, we are not losing any data, right? We are not losing any data. This is all because everything is implemented using the synchronization, right? When one thread is doing its job, the other thread should not come into the effect, right? Guys, understood? Most important question, you need to explain about this synchronization in a very detailed way, right? Practice with and without synchronized. Synchronized is just a keyword, just like public, private, protected, or abstract, or final. These are the various keywords we learned, right? So synchronized also one of the such keyword, but it gives a, this is the meaning. This will avoid, right? When the L1 thread L1 is thread L1 is starting, L2 will be, sorry, M1 will be waiting here. It will not enter inside this, right? It will not enter inside this. That means the lock is happening at this level here. The lock is happening at this level. There will be only one thread will go inside, and then it has to come out, then the second thread will enter inside this method, right? That's what is happening with synchronized. With synchronized, it will be simultaneous or sequential. It is sequential. Without synchronized, is simultaneous. Is simultaneous. You might think that this is the only thing you are seeing, and we are just making us a lot of complexity by implementing the threads and all. You can simply say that you just write two simple for loops and then you execute, right, without the multi-threading concept at all. But here in our learning program, this is the only logic we have, right? But in the real-time programs, here we have some thousands of lines of code, right? So that lines of that piece of code should execute sequentially or simultaneously, but there will be only one common resource that needs to be taken care with the extra care, right? So whatever that we need to put it in the extra care, that we need to synchronize it, right? Let's write some notes. This can be achieved by using synchronized keyword. Synchronized keyword. And we use synchronized keyword, only one thread will be executing and all other threads will be waiting for the thread that is already executing. I'm not saying first thread here. You need to, I'm very careful here. Only one thread will be executing and all other threads will be waiting for the thread that is being already executing. I'm not saying the first thread, because when the 10th thread is running, 1 to 9 also should wait, from 10 to 100 also, from 11 to 100 also should wait, right? Except the thread, all the other threads should be waiting. That is the reason I am very careful here to write that the waiting for the thread that is already running. Okay. If only one object, is allowing to use the shared resources, we don't need the synchronization. What does it mean is, if there is only one object, that means there is only one thread. There is no need of synchronization, right? Anyways, it will be only one. Synchronization is required only when there are multiple threads are running, right? In order to enter into a synchronized block, synchronized requires a object block, out block will not go to the synchronized method. It will not allow to enter the synchronized method. Every object will have only one object block. We have only one object as the full block. Side a non-static synchronized method not use static members. Non-static synchronized method is the simultaneously. Every class having a one class lock, class level lock. Keeping static synchronization. Okay, so we'll understand about all these points in the next class. Okay, you just go through it. It should be understandable, but we'll understand in the detail in the next class. Okay, we'll stop it here. You can ask any questions now.
Bro, can you upload the videos?
Sure, Raghu, I'll update today.
Sure. Thanks a lot.
Yeah. Anything else, guys?